January the 22nd, 2017. Guys, you're looking at an island that's just 41 kilometers west-northwest of Panguna, Papua New Guinea. The island is Orawa. But you see in this image, which is not a current image, we're looking at Google Maps, you see this volcano now. The 8.0 earthquake that has now been downgraded to a 7.9 hit inland. It didn't hit in the ocean, and that, let me back this thing out. And that was fortunate because when this powerful can cause a tsunami. Now, you can see the island has had volcanic history. You see that ancient crater. You can see other signs of volcanic activity across here. But this quake did ring the National Data Buoy Center. There's buoys going off all the way across the Pacific because of this. And that tells you the strength, and we'll take a look at it. Now, the quake happened here, and you can see the different stations that are showing alerts. Now, a lot of these are just a meter or less. Some are a little over a meter. Not that strong, but guys, this happened inland. So that tells you if you're getting this kind of shift, and that's what the diagram is showing here, it's roughly going from 3254 up to 3255 meters, guys. So it wasn't that big of a shift. If it had been offshore, I think the buoys would be picking this up, and it would probably be higher waves. Now, you can see all the way up into Alaska, the information is being picked up. We'll come around northwest of Australia. But again, this thing happened inland. And the reason I wanted to do it, because of this volcanic activity and this quake, I've been talking about the energy from the solar wind speed increasing that is being picked up by our magnetic field lines, transferred into the core of the planet. And we're going to start seeing the volcanoes. We're going to start seeing stronger quakes because of that. Now, again, we're looking at a kind of a strange situation because during solar minimum, the solar radiation is less. But because that solar stream generates the dynamo inside the core of our Earth that creates our magnetic shields, that our shields go down, so we absorb more what you would call galactic radiation, guys, or cosmic radiation. And that's what we're dealing with. So we're going solar minimum, cosmic radiation's increasing in the core of the Earth. And I did a video a couple of days ago, and they were talking about this magma core, or the magma outer core that surrounds a core, now can be measured through the swarm satellites. And it's telling us that it's moving 25 miles a year, the way that it's shifting. And that's strong, guys. That when you think about, when you look at the fault zones around this ring of fire, for example, you're talking about millimeters or inches a year in movement, not 25 miles. So that's a lot of torque. That's what we're dealing with. Now, a quick look at space weather. First, we've got a couple more sunspots coming around the sun. Yesterday, as they emerged, both of these were beta, and you've got two alpha. But check this out. Radiation clouds at aviation altitudes. As our shields get weaker, notice the solar wind stream is coming back down from over 600 kilometers per second. Very low density. Very low. All right. Radiation clouds are penetrating further into our atmosphere. This proves it. New study published in the peer-reviewed journal Space Weather reports the discovery of radiation clouds at aviation altitudes. When airplanes fly through these clouds, dose rates of cosmic radiation normally absorbed by air travelers can double or more. Now, this is put together by Dr. Tony Phillips at spaceweather.com. He also helps out and has set up Space Weather Radio that we listen to incoming meteorites. But it says we have flown radiation sensors on board 264 research flights at altitudes as high as 56,700 feet. Started in 2013, it goes until now. On at least 6 occasions, the sensors have recorded surges in ionizing radiation that we interpret as localized radiation clouds. The fact that air travelers absorb radiation is not news. Researchers have long known that cosmic radiation crashing into Earth's atmosphere creates a spray of secondary particles such as neutrons, protons, electrons, X-ray, and gamma rays that penetrate aircraft. 100,000-mile frequent flyers absorb as much radiation as 20 chest X-rays, and even a single flight across the USA can expose a traveler to more radiation than a dental X-ray. Conventional wisdom says that the dose rate should vary smoothly with latitude and longitude and the height of the aircraft. Any changes as a plane navigates airspace should be gradual. Says Tobisky and the colleagues have found something quite different, however. Sometimes dose rates skyrocket for no apparent reason. It surprised them. All of the surges they observed occurred at relatively high latitudes, well above 50 degrees in both hemispheres. One example offered in their paper is typical. On October 3rd, 2015, a research aircraft took off from southern Chile and flew south to measure the thickness of the Antarctic ice shelf. On board, the Armis flight module recorded a 2 times increase in ionizing radiation for about 30 minutes, while the plane flew 36,000 feet over the Antarctic Peninsula. Guys, think about that. That's where you have your field lines leaving the Earth that create our shield. It says no solar storm was in progress. The plane did not abruptly change direction or altitude. Nevertheless, the ambient radiation environment changed sharply. Similar episodes have occurred off the coast of Washington State. Now, this is one of the graphs from that flight and the study there over Antarctica, and it just shows as it comes in the spike in radiation, and the red area indicates where that cloud of radiation is. Those are the cusp in our solar shields. Radiation measurements made by Armis while flying over Antarctica. The colored points are from Armis. The black points are from a NASA computer model, NARIS, predicting radiation dose rates. Throughout the flight, Armis observed higher dose rates than predicted by the model, including a surge highlighted in pink. Now, he goes on to say that we're not sure what's going on, but we have an idea. Earth's magnetic field traps many cosmic rays and solar energetic particles in structures called magnetic bottles. These bottles can be leaky. Even minor gusts of solar wind can cause the trapped particles to be squeezed out the end of the bottle, sending beams of particles downward toward the Earth below. It says basically we think we might be flying through some of these leaky particle beams. Tobisky notes that a team of South Korean researchers has observed similar variations in radiation while flying sensors on board a military aircraft near the border between the two Koreas. If the phenomena are the same, the Korean measurements would suggest that the radiation clouds may exist at middle latitudes too. Think about that. When you see the entire shields of the planet, there's lines of magnetic field lines going in and out all over the planet. And so you create these energy spots or these radiation spots because of that. But that field is constantly changing. But guys, we're watching this. It's very interesting. Every time we see a new study, the radiation is increasing. Gamma radiation last year by 12.5%. Think about that. In the charts, in a video last week, we had 3% raise in gamma radiation over a 10-day period. Let's take a quick look at the Solar Dynamics Observatory. Now, this is giving us Earth-facing images of the sun. The two sunspots that have been in the center are moving to the right, but we have two new ones. Now, these aren't strong flares, but you can see they're some of the first that we've seen in quite a few months. So we also have Comet Honda directly in front of these sunspots. That's amazing, isn't it? It's as if they sense the comet coming in. We've seen two coronal mass ejections. We've got now about 20 days to close approach to our planet. It will be February the 11th. So it's going to be interesting to see. We're going solar minimum, but when an external event happens, the sun will react. It's a heads up, guys. Be safe.